Hello guys, I want to share an interesting question with you guys. So let's see the question first. The question is that x and y have joint density function, which is equals to 1 plus xy over a. And when the absolute value of x and y are smaller than 1 and 0 otherwise. So first we want to find the value of a so that the function is valid. So if the joint density function is valid, the integral of the function should be equals to 1. So since the absolute value of x and y is smaller than 1, so the integral interval is from -1 to 1. And since the integral of 0 is 0, so we only need to consider the integral from -1 to 1. So the integral of x of fxy from -1 to 1 is equals to that 4 over a. So 4 over a should be equals to 1, so a is equals to 4. So the second problem is that we want to know that are x and y uncorrelated. So if x and y are uncorrelated, it means that the covariance of x and y should be 0. So the covariance of x and y is equals to the expected value of xy minus the expected value of x times the expected value of y. So we need to find the expected value of xy and the expected value of y and x. So the expected value of xy is the integral from -1 to 1 xy times the original joint density function. So after the computation, we can know that the expected value of xy is equals to 1 over 9. And then we find the expected value of x, which is equals to the integral from -1 to 1 x times the original density function, dxy. So we can find that the value is 0. So the expected value of xy is not equal to expected value of x times expected value of y. So which means that the covariance of x and y is not equal to 0. So x and y are not uncorrelated. And since x and y are not uncorrelated, it implies that x, y are not independent. So we also solve the third question. So for the fourth question, we want to find the joint density function of x squared and y squared. So we can let the z be x squared and w be y squared, and then we want to find the Jacobian. The Jacobian is equals to the determinant of 2x 0 0 2y, which is equals to 4xy. And when 0 is smaller than 1 and greater than when 0 is smaller than z and smaller than 1 and w is smaller than 0 and smaller than 1, the Jacobian is equals to 4 times the square root of z and square root of w, and the joint density function of zw is equals to the summation of fxy over absolute value of Jacobian x1 and y1 to the density function of fxy of x4 and y4 over Jacobian absolute value of Jacobian x4 and y4, which is equals to 1 over 4 times square root of z and square root of w. So we know the joint density function of zw is equals to 1 over 4 times square root of z and square root of w. And when the value of when the value of z and w is smaller than 1 and greater than 0. So now we want to find the joint density function of z and w. So the joint density of z is equals to the integral from 0 to 1 of joint density function of zw dw, which is equals to 1 over 2 times square root of z. And similarly, we can get the joint density function of w, which is equals to 1 over 2 times square root of w when w is greater than 0 but smaller than 1 and 0 otherwise. So we can find the joint density function of fx squared and fy squared, which is equals to 1 over 2x when absolute value of x is smaller than 1 and 0 otherwise. And for the joint density function for y squared is equals to 1 over 2y when absolute value of y is smaller than 1 and 0 otherwise. And since we know the joint density function of fzw, and we can just transfer it to the joint density function of x squared and y squared, which is equals to 1 over 4xy when absolute value of x and y is smaller than 1 and 0 otherwise. So we done the first question, and for the final question, we want to prove or disprove that x squared and y squared are independent. So if they are independent, we can just need to check that the joint density function of x squared times the joint density function of y squared is equals to the joint density function of x squared and y squared. So since we know the joint density of x squared is equals to 1 over 2x and the joint density of function of y squared is equals to 1 over 2y, and the product of them is 1 over 4xy, which is equals to the joint density function of x squared and y squared. So x squared and y squared are independent. So we done the fourth question. Thank you, guys.